Good morning, everyone. My name's Damon Barnes. I'm the Director of Technical Marketing at the Bluetooth SIG. I want to start off today by saying thank you to the Things Conference for having the SIG here to talk a little bit about Bluetooth technology. It's a great honor, and hopefully this is something we can do again going forward in the future. Today, I'm going to talk to you a little bit about Bluetooth technology as a standard, and then I'm going to cover some of the major recent enhancements to Bluetooth technology that I think are quite interesting, and so share some information about those. And we'll specifically look a little bit at the feature called Bluetooth channel sounding, a distance measurement feature that was released last year, and talk a little bit about the performance of that feature, how precise the distance measurements can be, and a little bit about where we are with the rollout of the feature in industry. Okay, so the Bluetooth Special Interest Group, we oversee all things Bluetooth technology and all associated trademarks. We're a not-for-profit that's been around since about 1998, so about 27 years ago. The SIG, as far as how we operate, we like to say that we work to advance, protect, and promote Bluetooth technology. So advance is all about specification development and releasing new features and capabilities to the market. Protect is about qualification or certification, if you prefer. The SIG also oversees all things qualification testing. And then lastly, where my team resides, we're also the marketing arm for Bluetooth technology. So we're chartered with promoting, educating, evangelizing around the 5 billion plus Bluetooth-enabled products that ship each year. Speaking of device shipments, just a couple quick notes on Bluetooth technology, how many devices, how broad the technology is. So this year, this data provided by ABI Research projects that there are going to be 5.4 billion Bluetooth-enabled products that ship. If you fast forward to 2029, they're estimating 7.7 billion Bluetooth devices will ship. And so if you were to tally that up from, say, 2024 to 2029, that gives you a compound annual growth rate of about 9%, which is a really solid metric, especially for a mature technology like Bluetooth. So that's a little bit on the device shipments. Now let's talk a little bit or examine some of the enhancements that have come about recently that are going to supercharge or enable some of this growth. Actually, before we do that, though, quick overview of Bluetooth technology. So it was mentioned just a minute ago, there's actually two radio versions of Bluetooth technology. So you have Bluetooth Classic, that's basic rate, enhanced data rate, if you know the specification, and then, of course, Bluetooth LE. The two radio versions operate a little bit differently. They both function in the 2.4 unlicensed band, of course. With Bluetooth Classic, you have 79 1 megahertz wide channels that leverage adaptive frequency hopping. And then on the low energy side, we have 40 2 megahertz wide channels, also leveraging adaptive frequency hopping. As far as data rates go, Bluetooth Classic, you can achieve throughput or data rates up to 3 megabits per second. With Bluetooth LE, right, it's very broad. You have a longer range PHY where you can, extend the range, but you at lower data rates at 125 and 500 kilobits per second. Then you have the long-standing LE PHY, it's 1 megabit per second, and the 2 meg PHY. And later on today, if you're around when I speak again, you'll hear about how we're going to be increasing the throughput of Bluetooth LE. And then a couple more notes here. So Bluetooth Classic, the initial killer app, of course, was wireless audio streaming. There's lots of data transfer applications that are still applicable today, including HID devices. On the Bluetooth LE side, really broad, right? About 5 years ago, we released Bluetooth LE audio to the market. Lots of wearables applications, data transfer, LE HID devices now, HMIs, and lots of sensor-type devices like you see on the wall back here that take advantage of Bluetooth LE. And then along that same line, we have location services applications like asset tracking, item finding, and the like. And lastly, but certainly not least, Bluetooth LE also we have different methods to enable a large-scale device networking. We've standardized Bluetooth mesh networking over Bluetooth LE, and then we have large-scale, low-power star networks that enable deployments like electronic shelf labels. So that's a quick whirlwind tour of Bluetooth technology as a standard. So now let's take a look at some of those recent enhancements that I mentioned. So I was just touching on device networking. So for Bluetooth Mesh, the lead application area is commercial wireless lighting control. We actually have a lighting control standard called Bluetooth NLC. That's gaining great traction on the commercial space, and it's being written into third-party standards, so that's something we really like to see. And then on the electronic shelf label front, we have a standard that's called Bluetooth ESL, descriptive naming approach. There with that standard's also getting really good traction as well. It's public information that Walmart's been trialing standards-based Bluetooth ESL over the last couple of years, and they're in hundreds, getting close to thousands of stores deployed with Bluetooth ESL. And then in the middle of the slide, we have Auracast. Auracast is this whole new broadcast audio capability where you can transmit audio content to an unlimited number of receiving devices. Of course, consumer-type applications where you share audio from, say, a phone to friends' earbuds is an application. But then also where Auracast becomes really powerful is broadcasting audio in public locations like this event, for instance, silent TVs, like say in a hotel or bar, where you could broadcast, or you could tap into the audio that's being broadcast from a television and take in the audio from to your earbuds, and then fully have an immersive experience of the what's being played on the TV, like the football game I mentioned. And then lastly on this slide, let's start to talk more about Bluetooth channel sounding. Bluetooth channel sounding enables secure fine ranging between Bluetooth connected devices. The way we like to market this is that channel sounding enables this true distance awareness between Bluetooth devices. The lead application areas are Find My type solutions, and then also digital key or access control if you prefer. Automotive access control or digital key is actually the lead use case where we're seeing lots of traction, not only in the US and EMEA, but Greater China as well. So with that intro given to secure fine ranging and the recent enhancements, let's move to a little bit more detail about Bluetooth channel sounding. So Bluetooth channel sounding, the precise distance measurement feature within channel sounding is based on phase-based ranging. Phase-based ranging is this well-proven method in RF engineering for accurately estimating the distance between Bluetooth devices. And then also, Bluetooth channel sounding was designed for security from the ground up. There are multiple security features, multiple security levels that can be chosen or implemented with Bluetooth channel sounding, and this allows you to mitigate against known wireless ranging attacks such as spoofing and man-in-the-middle relay attacks. And a couple comments on the third bullet point you see here where we talk about brings true distance awareness. What we're talking about here, and the example I like to use is a smartphone, for instance. It's going to have a better understanding of its position in relation to the door lock, and then the same goes for the door lock, right? So this door lock is going to know when that phone gets close enough to precisely be in front of the door to unlock, and vice versa as well, to lock when the phone gets farther away. And then as far as the level of accuracy for Bluetooth channel sounding, we're communicating, or we're stating that Bluetooth channel sounding enables centimeter level accuracy, not necessarily 1 centimeter, but kind of like tens of centimeters accuracy. And we do have a member company that has an early implementation where they've achieved plus minus 20 centimeters up to 100 meters. And I have some performance data that I'm about to show you on the subsequent slide to support what I just said there. So speaking of the testing, so Samsung LSI and Lambda 4, an algorithm provider, partnered to provide some sample test results for us. about 9 months ago, right as the channel sounding feature was being rolled out. They used these prototype smartphones for the testing. The testing environment was an outdoor parking lot, so there was minimal interference, clear line of sight. The devices were stationary, mounted at about 1 meter high. They ran 3 rounds of tests. 2 of the rounds of tests at a +0 dBm transmit power setting, really typical transmit power setting for Bluetooth devices. And in the 3rd round of testing, they cranked the power up a little bit to 10 dBm. So with that given, I do need to state that I was, it was reiterated to me to state that these were early implementation results. Results may vary and all that good stuff. But so with that said, the first round of testing, this is what we had. So each device was set up with 1 antenna each, so that gives us 1 antenna path, 0 dBm transmit power. And what you see here is that even with just 1 antenna on each of the devices, the results were quite good. If you take a look at the line of sight row, you see that at 1 meter we were spot on, all the way up to 50 meters, it was plus minus 20 centimeters. So not real world testing per se, but really good consistent results all the way up to 50 meters. And then the second row you see there called back pocket testing. In this scenario, what happened, you have the remote device mounted stationary, and then the person takes the phone, puts it in their back pocket as the label suggests, and then you run the channel sounding procedure. So you have fading, right? And so here obviously there's going to be degradation, more of like a real world type scenario. And so you see the results here were, there was some degradation, and I have to call out at 5 meters, there was a pretty bad result. At the time of testing when they finished, the guys, they didn't have a good answer for why that result wasn't very good. But so we just chalked that up to being an early implementation that we think would kind of be ironed out over time. And why I say that is because the second round of testing that I show you, there's not that outlier there at 5 meters. And so the second round of testing, one device had 2 antennas, the other one had 1 antenna. So we have 2 antenna paths here. Again, transmit power setting of 0 dBm. Really consistent results all the way up to 50 meters. Spot on at 1 meter again, plus minus 10 centimeters at 50 meters. And then in the back pocket testing, as you see, the results were fairly steady all the way up to 50 meters. Now, for this last round of testing, here they set up the devices with 2 antennas each, so that gives us 4 antenna paths for the ranging procedure. They cranked the transmit power up to plus 10 dBm. And so here, again, the results were really consistent, fairly similar to the second round of testing, but a little bit better in some areas. And then in the back pocket testing, you see we actually got a better result at 1 meter and the same result up to 50 meters, but steady results across the, up to 50 meters. So at the SIG, we were really excited and happy to see the consistency and accuracy of these results that Samsung and Lambda 4 were able to deliver. So we got approval from them to share the information publicly. So over the last several months, I've been kind of like on a roadshow tour sharing this information with folks in the industry. Now, so let's turn to where we are in the rollout of the channel sounding feature. So you're enabling technology devices, think chipsets, modules, even stacks. Most of them, if they have a modern or newer Bluetooth LE solution, are going to support Bluetooth channel sounding. I've seen hundreds of devices in our qualification database today that are supporting the channel sounding feature. And then we're starting to see in-use products in media articles be mentioned as having support for Bluetooth channel sounding. I believe there were some Android, Google Pixel devices that were mentioned in a Verge article that channel sounding's enabled there. So in-use products are starting to appear that support Bluetooth channel sounding, and we think it's, we're just at the start. So more and more devices. We think the Bluetooth channel sounding feature is going to be supported very broadly. And why I say that is channel sounding supported in Android 16, including APIs, provided the link to the code search area of the website. within Android.com. And if you were to search for channel sounding, you would see a list of various channel sounding features, APIs, and support for the ranging for profiles and services to standardize the ranging procedure. And so you see the laundry list of companies that are supporting channel sounding publicly right now, or at least willing to allow us to say that. And so with that, that kind of wraps up my time for today. And so I really want to thank you all again for letting me talk to you a little bit about Bluetooth technology and give you a little bit of a little bit of information on some of the major recent enhancements that we have to Bluetooth technology. And I hope you'll come back later in the day to hear about the upcoming Bluetooth high data throughput feature that we'll be releasing next year. Thank you.
Thanks, Damon.